At this point, I'd like to hand it over to Mike Schatz and Anthony Philippakis, project directors of the AnVIL.
Hello, everyone. My name is Michael Schatz. I'm an associate professor at Johns Hopkins University, and I'm also the program director from the Johns Hopkins team representing AnVIL. Today, with Anthony Philippakis at the Broad Institute, we're going to start off the session today with an overview of the capabilities of AnVIL. Let me go ahead and share my screen so that you can see this. So first of all, welcome, everyone. When we had planned this, I don't know, more than a year ago, we had hoped to have an in-person meeting. So virtually, welcome to Johns Hopkins University. Welcome all of you. It's really great that we can all come together today to be here today. I know you've all seen this, but just at a very high level, our goals today are to give you an overview of some of the most important aspects of AnVIL. Today we'll really be focused on kind of the data side, and then as Adam mentioned, the billing side. This is a critical consideration. There's a lot of complexity when we're talking about the scale of data that we have today. On day two, we're going to be focusing on the compute side. So we'll talk about workspaces, how we can do batch processing, how we can do notebooks. On both days, there'll be a mix of sort of lectures where there'll be just slides presented, but also hands-on analysis where you'll get a chance to play with the system, really get exposed to how it works. And then also some breakout discussion groups where if you have questions, you want to learn more, that could be a great time to discuss that. As Mo mentioned, if you have a quick question, you can use the Zoom chat, but Zoom chat is very transient, it goes away. We really want everyone to use the Slack where you can kind of have a record. We can also easily break out into one-on-one conversations to help you through any questions that are there. So AnVIL is a very large project. It's organized through two separate awards, one that is centered at Johns Hopkins University, and then a second award at the Broad Institute. Although in reality, this is just a high level. There's about a dozen different institutions with many dozens of software engineers, analysts, outreach administrators, and other people that are really participating to build this whole system. So first of all, let me thank all of them on all of the hard work that they've done. I'm pretty good at PowerPoint, but it's really this team here that has really excelled in making all these capabilities come together today. So these are the people I want to thank foremost, and these are the people that are really going to be supportive to all of you, our users. We really want to build an active community, an active dialogue between developers and our community members so that we can learn from each other and work together on all these problems. Before diving into the content, I just want to really acknowledge what an exceptionally difficult time the last few months have been. Within the AnVIL team, we have lost one of our great friends, one of our great leaders, one of our great colleagues. This has been incredibly difficult and saddening. And then beyond his loss, as we're all facing tremendous hardships through COVID-19, and also the inequalities and racial discrimination that have taken place around the world. So we just wanted to take a moment to acknowledge these. We are delighted that you are all here and are able to work with us under such extreme circumstances. This is not how we would have chosen to do this, but we are really grateful that you are here today in light of all these complexities. So to open, I'd like to give you kind of a high-level view of some of the goals of AnVIL, and then I'll hand it over to Anthony to talk more specifically about the components that are there. As Adam just mentioned, and I'm sure as everyone on this call is aware of, the last 20 years have been quite transformative in genomics. 20 years ago, it was the heyday of Sanger sequencing when you had these very large facilities at individual institutions that were trying to make sense of genomic data. A really enormous transition occurred in the late, 2010, or around 2010, when we saw the advent of next generation sequencing. Shown here is a picture of arguably the original instrument, the Solexa genome analyzer. It was in many ways a step backwards from Sanger sequencing. The reads were very short, it was very unreliable. It was very complicated to use, but because it had this substantial throughput, it was just a very exciting technology to move forward on. And then here we are a few years later, where we have NovaSeq and other very high throughput instruments that we all use that have really transformed the field. And now we can do and tackle problems that were just unthinkable just a few years ago, thanks to this really improved technology. On the computational side, we're seeing a sort of a similar trajectory play out. Back around 2000, it was really dominated by institutional clusters, where there was a big model where you would generate data, you'd have to copy it into your cluster, you'd have to set up these complicated workflows. It was slow, it was relatively expensive to set up because every institution had to have this redundancy, but it was the way that science was done. A few years later, we saw the emergence of cloud computing in genomics for the very first time. This touched my own personal experience in that during my grad school career, I had an opportunity to be a very early access customer. It was extraordinarily exciting to me to be able to boot up virtual machines in the Amazon cloud, get access to untapped resources, but it was extremely complicated. You had to be an expert level programmer to develop, you had to be an expert level a systems engineer to set up the systems. It had great potential, but was clearly not ready for prime time. But here we are a few years later, and I like to think that genomics in the cloud is ready for prime time, where now we have a unified platform where we can integrate tools, data sets, authentication, running in a highly scalable environment where we can really tap into these resources and make great scientific discoveries. Ultimately, that's our main goal, is we want to make a platform that will be as efficient and as powerful as your local cluster, but much more scalable, much more comprehensive, much more integrated. Let's turn every user into a power user at scales and complexities that were never envisioned before. Essential to this is we're going to invert the model of data sharing. Historically, the process for data sharing has been data is deposited, for example, in a central repo, and then everyone that wants to look at it has to download it, has to set up all the tools locally, has to build a lot of infrastructure to make sense of it. Well, let's invert that model. Instead of having every user at every institution have to build all these resources, let's build shared capability that everyone can tap into, and then we'll make it very easy to bring users to onboard into this new system where they can tap into this great sophisticated environment. So rather than bring data to the researchers, let's bring researchers to the data. We'll avoid all this redundancy. It'll be much greater accessibility. There'll be new opportunities at scale. There'll be new opportunities for data integration that would be impossible to do at any one institution. So our real goal here is to build you a system that can do things that have never been done before. To describe the system in a little bit more detail, I'm going to hand it off to my partner, Anthony Philippakis at the Broad, to talk a little bit about what is AnVIL.
So thank you. Just to chime in a few things. First, what an honor it is to be able to be with all of you today, and very excited to launch this next phase of access to NHGRI data. So to kind of speak to a little bit more about the AnVIL and its goals, we think of it as actually having a few different components. So the first is, as Mike said, there are real advantages to cloud computing going forward. As Mike said, it's highly elastic, but most of all, we all benefit from being able to access the same copy of the data so that we don't have to continue in this world where every data set is stored at every major medical center. Beyond that, one of the hopes is that we can provide access to data in a more streamlined fashion. Both genotypes and phenotypes that are generated through large NHGRI programs, whether it be the GSP or eMERGE or CSER. And then once you've got access to data, to provide you with secure and compliant workspaces where you can bring together data and tools to perform analyses. And most important, to do this in a way that is collaborative, where you can let in your friends while still maintaining a certain level of security and privacy until you're ready to show your results to the world. And with this comes a lot of security and compliance that's baked in so that your organization's team doesn't have to take care of it, which again greatly limits to access to these data sets because not everyone has a compliance group that's up to the task. So when we think about the AnVIL, one of the things that I want to stress is that it is very much designed to create a federated ecosystem of applications. The goal here is not to create one monolithic data platform that does all things for all people. I think that would be very hard to achieve, and also it wouldn't be good for the world. What's much better is if we create an environment where there are an ecosystem of applications that can talk to each other and move data and tools around between them. The key components for the AnVIL include Gen 3, which provides a data repository for various data sets, Galaxy, which provides an analytical toolkit and environment, RStudio Bioconductor, and Jupyter, which provide collaborative notebooks for performing interactive analyses. And then finally, DocStore, which is an environment to share workflows with these other applications. And so we're at various stages of integrating all of them. The focus today is going to be much more on Terra workspaces, as well as Bioconductor and Jupyter. But over time, you'll be seeing a much greater presence from Gen 3 and Galaxy and other applications too. And as I said, one of the things that we take very seriously is our approach to security and compliance. All of the applications that you see live behind a security perimeter that has undergone extensive third-party auditing and compliance review by folks at the NIH and other places. To put a more technical term, it's what's called a FISMA moderate environment. And this is actually a very high bar to clear. Took more than a year when we first went through it to get it implemented. And all of this that you see is built on top of the Google Cloud platform, and they handle a lot of the billing, and we access many of their lower level services. Then finally, beyond just the applications, one of the things that we're striving to do is to create a channel to interact with users, disseminate information, update you on new events, whether they be data sets or tools or onboarding events. So anvilproject.org is the homepage for this event, and it's built collaboratively amongst all the teams that Mike listed. And one of the things that you'll see as you go to AnVIL Project is that we update regularly what data sets exist. And as I said, there's about more than a petabyte of data available already, and it's growing very rapidly. Also, something that I want to highlight that's very core to the mission of the AnVIL is trying to streamline the approach by which researchers get access to data sets. Our current approach is that genome centers and other groups who are large-scale data generators deposit them in dbGaP, and at the time of deposition, provide a data use letter that summarizes the appropriate secondary uses of the data. So for example, it's not uncommon to hear that this data set is only available for cardiovascular research in a nonprofit setting. Then we as researchers fill out applications to gain access to this data set. And currently, this is reviewed by a data access committee at dbGaP. Now, dbGaP has been much better than almost any other data access committee in terms of its turnaround time, et cetera, but it's still a very large amount of work for them. And one of the experiments that we'll be running, it's not featured so much today in our program, but will be very much a part of what we're doing going forward, is to try and make a lot of the steps of gaining access to data sets more automated and streamlined, so that you can apply for multiple access to data sets simultaneously, and even ideally across many NIHICs. As I said, this is very much a work in process. So to highlight some of the data sets that are in there already, and ones that will be coming, CMG, CCDG, eMERGE, GTEx, and 1000 Genomes are all available. Then the CSER program is underway, but will be continuing throughout the year. Then we have another set of data sets that are just getting going, and these include some intramural COVID data sets for the Host Genetics Initiative, the Undiagnosed Disease Network, which is likely to be of interest to many of the CMG researchers and beyond. And then also several other NIHICs have started discussions about whether it might be possible for them to leverage the AnVIL, including NIMH and NIA. Next slide. Also, as we mentioned, one of the goals of the AnVIL is to create an ecosystem of fellow travelers. So to govern the AnVIL, we've created various working groups. These include the data processing working group, which is responsible for selecting the pipelines that will be used to process the data at a read level, as well as defining QC metrics and metadata models, et cetera. There's a similar working group that decides on the standards for phenotypes and how they're represented. And then there's also the data access working group, which, as I said, is iterating to try and bring duos forward. And so if any of you are interested in joining these working groups and some of the other ones, again, we very much welcome participation, and feel free to reach out to Mike or I or any of the organizers of this event. Just to talk a little bit about what you're going to be seeing today, we think of analyses as coming in two flavors. So first, there's batch computing, by which you think of the kind of standard bioinformatics approach of building pipelines and then running them on the cloud. And we hope that a lot of what we present today will make it easier for you to run various pipelines, especially popular ones for genomes and exomes. So that rather than having to have someone at your organization string together the tools and figure out how they can be deployed in your local infrastructure, it'll instead be possible to be able to just, with a few mouse clicks, start a process. Then the other side of the coin is, in addition to batch computing, where you're running kind of longer running processes and then monitoring them, is the approach to doing more interactive analytics. And so again, one of the things that we make a lot of use of is Jupyter Notebooks, and that'll be very much featured today. Next slide. In addition, we've done a lot of work to do RStudio. And here, one of the really key members of the AnVIL community is the Bioconductor group, which many of you are very familiar with, which is a tremendously popular open source software package for bioinformatics that's been developed over more than a decade now. And again, we've tried to make these environments very well integrated into the AnVIL and available for you to use. Additional components, today you'll be accessing data through workspaces, but going forward, and this will hopefully play out relatively soon, you'll be able to use the Gen 3 system to search for data sets across a variety of different cohorts, build synthetic cohorts, and then migrate them to a workspace where you can perform deeper analyses. And here are a few screenshots of that. And again, as I said, you'll be seeing more of this in the future. And then also, we believe in not just sharing data, but also tools. DocStore provides an environment for researchers to share tools with each other. It's developed by our friends at UCSC who are part of this award, and it's a tremendously popular tool sharing repository. And then finally, we hope that this will be available in October. The Galaxy environment is a tremendously popular tool for running analyses that's been developed over the last 13 years by our friends at Hopkins. And one of the really important goals of this effort is to integrate the Terra environment and its workspaces with Galaxy so that people can access all of its tools and its great UI for building and running pipelines in a manner that's secure and compliant and accesses all of the data in the AnVIL. And just to speak to the last slide as it loads, as I mentioned before, the things that I've listed out here are very much the starting point, but not the ending point. Over time, we'll be enriching these with a lot of additional applications that target various users and various user communities. Moreover, there are starting to be many different NHGRI programs for which the vision for the AnVIL is baked in from the start, whether it be the next generation of CMG or Mendelian Genetics Awards, or the next phase of eMERGE. And maybe with that, I'll close out, and Mike, I'll let you take over for the ending part.
Okay, thank you, Anthony. Thanks you for giving everyone an overview of the capabilities. I'm having a little technical difficulty, so I'm just going to use this display here. So, over the next 2 days, you're going to hear a lot more detail about how all these system works, but I just wanted to highlight a few resources that are available right now, so that just so you have pointers to this available right now. There's a number of guides, FAQs, featured workspaces, other sorts of resources that you can go check out right away. We also have a mailing list that you can contact if you have sort of questions. Over time, though, we want to see more. We want to see a community developed. We want to see an ecosystem develop. So we're hoping that this community Slack will really take off as a place to build and really interact in real time with different developers and other users. In addition to those resources, we have extensive plans and extensive activity for more training and outreach. Our goal here is to provide open source resources for everyone. So we're going to be building a lot of workflows. We're going to be also building MOOCs where you can really get a deep dive into how these different approaches work, the different algorithms. We're also going to be building an extensive training network that is going to develop scientific resources for different analysis tasks. One of the nice features of this is we have automated systems in place that can take a Google slide deck with a few notes and then automatically render it into videos that you can then go watch. In fact, all of the slides that we were generating from the Jamboree over these next 2 days, in about a week's time will be available through the portal, so you can go back and review the videos, review the slides, review all the notes. So if you're taking notes at home, that's great, but all of these resources will be available, all the videos, everything that you can need. Another important capability of this is that we'll be able to rapidly do some very interesting things like on-the-fly translation from one language to another, so we can have as broad as outreach as possible to all sorts of communities around the world. As I mentioned, we're building a training network that will have a lot of sort of scientific analyses where you can kind of walk through step by step, explain the goals, explain the methods that are necessary, explain the data requirements, and explain how you would interpret the results. There's a lot of, genomics is enormously complicated. There's a lot of different analysis that need take place. Not every person is an expert on everything. In fact, no one is an expert on everything. So these resources will be a way that we can all learn from each other. In addition, we're building essentially college-level courses through MOOCs that will hopefully turn you into experts onto data science in genomics, so you can be very sophisticated in the types of work that you can do. So the last thing I wanted to highlight is AnVIL is a work in progress. We have a lot of capabilities that are available today, but there's a lot more that will be available in the near future. Our roadmap extends for years and years in the future. We see this as becoming a core part of NHGRI to support a lot of different projects and consortium of forming. So if you have a favorite tool that's not available today, don't worry. We probably have it on our roadmap. If you want to talk to us about getting yours onboarded, please do so. We welcome that through our community. So there's a roadmap on both the technology side, events like these, to kind of learn in more detail about the capabilities that are present. So with that, I'd like to thank you. We're only 2 minutes late, so I'm pretty happy with the time. If there's any sort of very urgent questions, maybe we can do a couple, but really, you may want to pause because the whole rest of the Jamboree is going to do a deep dive through all the different systems that we highlighted just here.